And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of Lead Code and Geeks for Geeks within less than 5 minutes. So without wasting time, let's get started. So today's problem is Kadane algorithm, which is marked as a medium level problem and it's a very common interview problem as well. Alright, let's find out what we will be given into this problem and what we have to do. So we will be given one array ARR of integer types and its size can range from 1 to 10 raised to the power 5. Okay, all right, and its elements can be anything from minus 10 raised to the power 9 to 10 raised to the power 4. Okay, all right, so let's find out what we have to do. So we have to find and return the maximum sum possible from all the subarrays. From all the subarrays we have to return the maximum sum possible. Okay, so what does this mean? This means we can take only subarrays. Subarrays basically means continuous array parts. Like this is one subarray. Okay, this is one subarray and this is one subarray in this way. So and we have to return the maximum sum possible of any smallest subarray. Okay, all right, now you will be thinking like, what's the issue? Just take the sum of whole array and return. Because but look, we have the negative numbers as well. We have the negative numbers as well. So for that, look, if you will take this much array sum, it will be what, in negative, but if you will take this much array sum, it will be in positive. Okay, all right, similarly if you will take this much whole, it will be positive, but if you will take this much, it will not be there. So it's basically we have to check all the subarrays. We have to check all the subarrays. Okay, all right, but checking all the subarrays, which means to have two nested loops, which will be resulting in n square time complexity, which will give us time limit exceed. Okay, all right, so what's the solution then? The solution is very simple. Okay, so that's what the solution is. Look, we want to do it in linear time complexity, but how, let me tell you. Look, I will start from this 2. Okay, and I will have one answer number which will be currently equal to, let's say, okay, all right, I will be having one answer variable which will be in 2, which will be like the zero index, that is 2. Okay, and current sum is equal to 2 as well. Current sum is equal to 2 as well. Okay, all right, I will then go to 3. Okay, so if the number is positive, I will simply add it to current. Because yeah, I can take it. Like, if number is positive, what's the issue? If your friend has good qualities, what's the issue in that? No issue. So we will simply accept it, and now my answer will be 5. Okay, all right, after that I got -8. After that I get -8. Okay, so should I take -8 or not? Like look, I will take -8. But should I take with the previous whole subarray, or I should take it independently? Okay, so what should I do? Okay, look, if I will take -8, I will take -8 only. So my current sum will be what? -8. But if I take the whole subarray, 2 3 -8, my current sum will be what? -3. Okay, so -3 and -8. -3 is smaller, -3 is greater, so I will take the whole subarray, and now my current sum will be -3. Okay, all right, so that is one thing. Current is currently -3. Okay, now I got 7. Okay, so should I include this whole subarray? Like, currently my subarray is or 2 3 -8, and then I include 7, or I should start a new subarray from 7? If I will start a new subarray from 7, my current sum will be 7. If I start the whole old, like continue the old subarray, my sum will be what? 7 minus 3 4. Okay, so if you know one thing. If you have, let's say, a balance in your sim, and that balance is now negative, and you don't want to include it, so what you will do, you will buy a new sim instead of having some negative. If there is some negative balance and then you have to add it, so you will not take that. You will take a new sim. I'm just giving an example. So that's why you will take 7. Instead of continuing the old array, you will start a new array with the 7. Okay, and now answer will also be updated to 7 because current maximum is 7. So in this way we will keep on doing, and at last we will simply return our answer. I hope that will be clear, and if yes, let me go to the code section and I will write the code for it. But before that, if you have loved the explanation, please don't forget to subscribe the channel and like the video. And I'm developing one more cool thing. Let me show you a small feature of it. So GFG POTD solution, if you will click on it, you can simply watch all the videos of cadence algorithm here only. No need to go on YouTube. Okay, so you can click here
Hello
and
guys,
that all, and that's it. So I will publish it on Google Chrome as well, and you can download it from there, but it's still in development process, so I just showed you. Okay, all right, so let me write the code it for you, and let me tell in comments as well ki how is the idea of extension. Okay, all right, so int answer is equal to what? ARR of 0, and current sum is equal to ARR of 0 as well. Okay, all right. Start from 1 for int I is equal to 1, I is less than arr dot length I plus plus, and what I told, look, sum will be equal to what? Math dot max, sum not sum, current. Current will be math dot max of current plus arr of I, otherwise arr of I. Look, I have to include arri. If I'm at minus 8, I have to take minus 8. If I'm at 7, I have to take minus 7. The only question is, should I take it with the continue the previous subarray and include our 7 to it, or I should start a new subarray with 7. So if I will take the old subarray and add, so it will be current plus arri. But if I start a new subarray, the current sum will be what? Only arri. Okay. All right. And now answer will be what? Answer is equal to math dot max of previous answer and current. Okay, all right, and at last simply return current or simply return answer. So yeah, that is it guys. It's a very easy problem, but the thinking is a bit requires a bit logical thinking. And if you have loved the explanation, please don't forget to subscribe the channel, and I'm going to see you again tomorrow, and maybe the extension will be published as well. So tell in the comments how much are you excited. And all right, bye.